Hi everyone, this is a look at moles. Moles represents 6.02 times 10 to the power of 23 particles. This is called Avogadro's number. That's a really big number. Atoms and molecules are amazingly small. Specifically, moles are a way that we use to simplify the way that we communicate about substances. Instead of saying, oh, in this experiment, I need 6.02 times 10 to the power of 23 atoms, I can just say, oh, this experiment requires 1 mole. Because of that, and almost more important than that, it's a way for us to convert between mass and atoms themselves. We have this formula, lowercase n equals lowercase m over capital M. It's the moles, lowercase n. That's a little bit strange. N is the symbol for moles, which are measured in moles, M-O-L. That's going to be consistent throughout all of chemistry. Lowercase n is moles. M is the mass. Really important to stress here, this must be in grams. A lot of the time questions will provide us the mass in grams, but we have to be on the lookout for those times when we maybe have kilograms, milligrams, or even something like megagrams. Capital M is the molar mass. That's the value based on the formula in combination with the masses that we can find in the data booklet. It's one of the most common calculations that we're going to encounter in chemistry. We can use it to find the moles. In different scenarios, we might be asked to manipulate this equation to calculate the mass, moles times molar mass, or very rarely, but still a possibility, we might be calculating the molar mass using this formula, which is the mass in grams divided by the moles. Here's a couple of examples. Determine the moles present in 50.0 grams of carbon dioxide. This is saying determine the moles. Calculate the moles. How many moles is it? It's mass over molar mass. Moles is the mass over the molar mass. The mass is right in the question, 50.0 grams. That's really important. We need it to be in grams. We have 50.0 grams. Divided by the molar mass. The molar mass of the chemical involved. Here it's carbon dioxide. What's the molar mass? Now, if we need to go off on the side and work that out, fantastic. We need to do what we need to do. In the end, we hopefully can just do this without writing anything down. For now, I'm going to write it down. Carbon dioxide is CO2. CO2, that's 1 carbon and 2 oxygens. I need to go to the data booklet, find carbon, it's 12.01. There's only 1 carbon in CO2. And now there's 2 oxygens each, the data booklet tells me, with an atomic mass of 16.00. So I take my time, and I have the molar mass 44.01. And that goes into my formula here in the denominator, 44.01 grams per mole. Now I just do the calculation, 50 divided by 44.01. Turns out to be 1.136,105,431. I need to apply my significant digit rules. In the question, 50.0 just has which has 3 significant digits. So my answer, I need to round off to have 3 significant digits as well. Here is 1.14, and these are the moles that we calculated with the units mole, M-O-L. 50 grams of carbon dioxide is 1.14 moles of carbon dioxide. A second example. What is the mass of 0.325 moles of ammonia? Pretty explicitly, what is the mass? Here, if we look at the formula, the mass is the moles multiplied by the molar mass, N times capital M. The mass is the moles multiplied by the molar mass. The moles are right in the question, 0.325 moles. Now I need the molar mass of the chemical in the question here, ammonia. That means I need to find the formula, I need to use the data booklet to add up the individual masses. Ammonia. Maybe I don't even know the formula for ammonia, but I notice it's a one-word name. I can find the formula in the data booklet. It's NH3. Now I need to work out the molar mass. Notice that both of these questions, whether we were going to calculate the moles or calculate the mass, we had to think about the chemical formula and figure out the molar mass. NH3, that's 1 nitrogen and 3 hydrogens. I go to the data booklet if I need to. Nitrogen is 14.01, there's only one of them. Hydrogen is 1.01, and there's 3 of them. When I add all of that up, it's 17.04 grams per mole. That's the molar mass of ammonia. Now I do my calculation. 0.325 times 17.04. What shows up on my calculator screen is 5.538. That's the raw answer. It's the answer, but it's not quite finished yet. It's raw. We need to think about the significant digits and the units. 0.325, the one number in the question, has 3 significant digits. So just like the last example, our answer must have 3 significant digits as well. Here, it's 5.54, and we found the mass in grams. Moles, it's one of the most important ways we have to communicate amounts in chemistry. There's a really fundamental kind of calculation, mass divided by molar mass, that we can use to calculate the moles or to find the mass or even the molar mass. Here's a couple of examples. Notice that both questions, even though we used different manipulated versions of the formula, had us thinking about the formula for the chemical and calculating the molar mass. And I hope that helps.